Okay, so in this video, we are going to talk about Archimedes' principle. It's a pretty simple principle. So to understand Archimedes' principle, we're going to make a figure. We're going to make a beaker filled with water. So we have our beaker filled with water. Now we're going to dip a stone here. Now what's going to happen is when we dip a stone, some of the water is going to come up. This is our increased water, and the next thing that's going to happen is the water is going to give some upthrust on the stone. So we're going to write this as upthrust. So that's the upthrust on the stone by the water. We're going to call this increased water displaced water, and now we're going to relate these two things together. So we are going to actually calculate the weight of displaced water and then compare it with upthrust. Now, first of all, to calculate upthrust, we are going to weigh the stone in air. So let's say the weight of the stone is 10 Newton, and the weight of the stone, the same stone in water is just 8 Newton. So how did the weight decrease? So it decreased because of our upthrust, and so the upthrust we can calculate it simply by subtracting those two weights, which is 10 Newton minus 8 Newton. We have our 2 Newton, and that's our upthrust. Now we're going to calculate the weight of displaced water, and we just made a pore there so that all the displaced water can come out from here. We're going to collect it in a beaker, and then we're going to weigh this displaced water. So when you weigh this displaced water, what happens is the weight of displaced water is also 2 Newton. So what's happening here is the weight of displaced water is equal to the upthrust, and that's kind of surprising, and that's what Archimedes' principle is all about, which is the weight of displaced water is equal to the upthrust. And now we are just gonna write the same thing here. The weight of displaced water is equal to the upthrust, and that's all Archimedes' principle is about. So if we need to write the statement, we can write it somewhat like this. So if an object is fully or partially immersed in a liquid, whenever we dip something inside water, what happens is it's gonna feel some upthrust, or there is going to be some upthrust on that object. So we are gonna write it experiences certain upthrust, and that upthrust is equal to the weight of displaced water. So that upthrust is equal to the weight of displaced water, and that's it. The first part is just about dipping something inside water, and we have our relation of upthrust and displaced water then. So certain upthrust and weight of displaced water, and they are equal. Thank you.